Hi, everyone. So let's now talk about different forms of difference quotients. So the first form I discussed involved fixed values for a and b, and therefore fixed function values. Well, the form of the difference quotient is the slope of the secant line, rise over run, f of b minus f of a all over b minus a. You should know that. This is the average rate of change of f on this interval. I'll skip the next two forms. I'll go straight to form 4. This is where the x-coordinate here might vary, and the run, h, might also vary. So here, it's like we have a point with x-coordinate x rather generically, another point here with x-coordinate x plus h. The run here is h. In fact, h could be negative. The point could be over here to the left of this point. Again, the slope of the secant line is given by rise over run. So f of x plus h minus f of x all over h, the run here. We'll see this when we develop the limit definition of derivatives in the next section. Now, let's apply the first form. A company sells widgets, a fictional object. Assume that all widgets produced are sold. Maybe a widget is a gallon of ice cream. Let P be the profit function for the company. P of X is the profit in dollars if X widgets are produced and sold. So our profit model looks like this. P of X equals the opposite of X squared plus 200X minus 5,000 in dollars. Find the average rate of change of profit between 60 and 90 widgets. So if we increase our production from 60 widgets to 90 widgets, what is our average rate of change of profit? We're going to treat the domain of P as the non-negative reals. So maybe it's appropriate that widgets are like gallons of ice cream. You can have non-integer values like 3.5. These aren't like cars. Okay. So we want to know the average rate of change if we go from 60 to 90. Well, it's going to be similar to form number 1 here, except that instead of the f function, we have the p function. We know that we're going from 60 widgets, a equals 60, to 90 widgets, b equals 90. So on the top, we have p of 90 minus p of 60 over 90 minus 60. We want to simplify this. This is the average rate of change of profit going from 60 widgets to 90 widgets. Well, here's the formula for P of X. P of 90, plug in X equals 90. P of 60, plug in for P of 60, plug in X equals 60. You might want to work these out separately. Here, it's one big formula here. And also, don't forget the grouping symbols. If you don't work these out separately, then definitely put grouping symbols around the second group. They're not as necessary in the first group. Divided by 90 minus 60 is 30. All right. So work it out, and we get, now, P of 90 minus P of 60, this numerator, P of 90 minus P of 60, the change in profit is $1,500, going from 60 widgets to 90 widgets. We're dividing by the 30 widgets, the run. So the difference quotient is $50 per widget. Remember, it's dollars of profit over widgets. It's the P unit over the X unit, basically. Dollars per widget, $50 per widget. So again, the practical interpretation is that if the company increases its production from 90 widgets to from 60 widgets to 90 widgets, then its profit will increase by a rate of $50 per widget on average. The total increase in profit is $1,500 and is spread out over the 30 additional widgets when you do the average rate of change. Again, the difference quotient gives the slope of this orange secant line. Rise, the total change in profit, over run, the increase in the production level. $1,500 per widget. That's the slope of this orange secant line. The fact that the slope is positive, it's an upward sloping line, reflects the fact that the profit function is increasing in that vicinity. Over here, the average rate of change of profit would be negative. And up here, it'd be more of a wash. We're going to skip the next two examples. Let's go straight to example 5. Again, same profit function, P of x equals the opposite of x squared plus 200x minus 5,000. Evaluate and simplify this expression. The difference quotient, P of x plus h minus P of x all over h. Two tricky things here. For P of x plus h, how do you write that out? Hint, it involves what? S word. Substitution. You're going to substitute x plus h in parentheses into x here and here and here. Also over here, when you plug this in for P of x, you're going to need something. You're going to need grouping symbols. All right, so this is a big first step here. Many students, if they can make it to here, they're set. So P of x plus h, we're going to do a bunch of substitutions. The opposite of, instead of x squared, is the opposite of the square of x plus h. Plus 200 times, instead of x, it's the quantity x plus h. Minus 5,000, nothing changes there. Minus, again, don't forget the grouping symbols, because you're subtracting something with more than one term. And we just have the P of x rule, the opposite of x squared plus 200x minus 5,000. All that goes over h. Rise over run. If you get this, you're set. Now, it helps to square this binomial. The opposite of the square of x plus h is not just x squared plus h squared. It's x squared plus 2xh plus h squared. Don't miss this middle term. So after this step over here, a key error to avoid is that you need to remember to not miss the middle, the 2xh term. Plus, here I'm distributing, we can wait, 200x plus 200h minus 5,000. Minus, in brackets, again, copying P of x. All that over h. Then I distribute the negative 1 through here, the opposite of x squared, minus 2xh, minus h squared. If you haven't distributed yet, distribute, plus 200x, plus 200h, minus 5,000, minus, again, don't forget the grouping symbols, or distribute the negative 1 right now. Do one or the other. All over h. Now, when I distribute the negative 1 here, what ultimately happens on the top? It's a massacre. So we get the opposite of x squared minus 2xh minus h squared plus 200x plus 200h minus 5,000. Then we flip all these signs here. Plus x squared minus 200x plus 5,000. And we get a bunch of cancellations. The opposite of x squared and the x squared, they add up to 0. That's a cancellation. 200x minus 200x, that gives 0. And negative 5,000 plus 5,000, that gives 0. There are only 3 terms that survive on top. Write them out. Make sure you put this as a separate step. Don't combine too many steps at once. What survives on top? Negative 2xh minus h squared plus 200h, all over h. Now, what can we do on the top? We can factor out what? We can factor out the h. H times the quantity, when you factor your divide, negative 2x minus h squared divided by h is h, plus 200h divided by h is 200. all over h. H divided by h is 1, provided h is not 0. That's a hidden restriction here. So finally we get the negative 2x minus h plus 200, provided h is not 0. So we don't want h to be 0, but when we do derivatives in the next section, we're going to let h approach 0. So whatever x and h are, this here is a formula for the slope of the secant line. This is a very handy-dandy formula, because remember the earlier example. In the earlier example, we asked what was the average rate of change of profit if production went from 60 widgets to 90 widgets. Well, we can now use the handy-dandy formula. We don't have to work a difference quotient out. We already have a handy-dandy formula. Negative 2 times, we start at 60 widgets. That's the starting point. We start with x equals 60. Now, if we're increasing production from 60 widgets to 90 widgets, what's the run? 90 minus 60 is 30 widgets. Okay, that was the denominator in our earlier example, 30 widgets. Minus, again, h is 30. That's the run, plus 200. Okay, and this turns out to be, guess what? 50. The unit for y, or profit, is dollars. The unit for x is widgets, $50 per widget. $50 per widget. And that was the average rate of change we found back here when we just plugged in numbers. Up here, we found the average rate of change of profit between 60 widgets and 90 widgets. Okay, instead of having to go through all this, we had the handy-dandy formula, and we got the same result, $50 per widget. Although, of course, we did use a difference quotient, and we simplified it in order to get this formula in the first place. But now that we have this formula, you can quickly answer questions like, okay, so what's the average rate of change of profit if we go from 100 widgets to 200 widgets? Well, we can do it right now. Negative 2 times x is 100, minus the run h is also 100 if you go from 100 to 200 widgets, plus 200. All right. Negative 200 minus 100, that's negative 300, plus 100, we get negative $100 per widget. Which makes sense because by the time you're out to 100 to 200 widgets, you're out here. And we know that the profit function is sloping downward. So it's negative. Our profit is decreasing. All right, handy-dandy formula. Next, what happens if h approaches 0? We get what's called the derivative, which is a keystone of calculus.